Okay, good afternoon, everybody. And today we're going to start our discussion about a topic which I think most of you actually have some knowledge of already. At least it's a topic that is relatively familiar to you, and that is the use of fingerprinting and fingerprints in forensic science. And now the use of fingerprints actually goes back a very, very long way, not necessarily for the purposes that we now use them, but it has been recognized for a very, very long time, if not thousands of years, that fingerprints have some unique quality to them. And they have been used as a method of identification in various parts of the world, in various places, over a very long period of time. So, for instance, in China and in India, using fingerprints as a means of getting people to sign things and things like that, that is a very ancient practice, even though people didn't necessarily understand that every fingerprint is actually unique. Now, I want to remind you that we talked at the very beginning of this class about how this systems of identification of individual human beings are recognized as being tremendously important. And so the first kind of system to try and develop a systematic classification of human beings by their characteristics was developed by Alphonse Bertillon. And it was a system of anthropometry. That means measurement of human characteristics. And that was a very cumbersome system. And it had the disadvantage that it didn't have any predictive quality to it. A person at a scene of a crime did not leave behind evidence of their Bertillon measurements. It was a good way if you had somebody in custody, got their Bertillon measurements. If they were subsequently found, for example, in another jurisdiction and their Bertillon measurements were taken, there would be a good chance that you could match the two and identify, even if they were using a pseudonym or whatever. But it had no predictive quality to it. But this is the great promise of fingerprints, is a fingerprint found at the scene of a crime can be tied to one particular individual, provided you have that information, provided you can compare your suspect fingerprint to a standard and link them. That is the caveat to the whole system. So the very first is, oh dear, I think. Oh dear, I think I was on mute. Thank goodness I noticed. Okay, let's go back. I'm sorry. I'm going to start again. Okay. Let me just check everything. Right, okay. Thank goodness I noticed so soon after I had started. Okay, fine. Excuse me, I've got to go right back to the beginning. Yeah, okay. So here's what I said at the very start. We're going to be discussing the topic of fingerprints and fingerprinting. And this is something which is probably familiar, has some familiarity to you. Certainly something that you've heard about probably your whole lives. But the use of fingerprints actually goes back a very, very long way. The use of fingerprints is probably thousands of years old. We have evidence, for example, that in Babylonian systems, they imprinted people's thumbprints into clay. Chinese, Indian systems used actual fingerprints. They took ink prints, although there was probably no realization that every fingerprint is unique. It was a way of impressing a personal identification onto a document, for example. Now, I'll remind you that very early on in forensic science came this realization that we need systems of identification where we can identify an individual. And that, doing so is actually not that easy. The first working system to do so was developed by Alphonse Bertillon. And Bertillon was a French forensic investigator who developed a system called anthropometry, where he measured particular body measurements, length of the forearm, for example, length of the shin, length of the foot, etc., put them together into a very complex formula, and was able to develop a Bertillon measurement for each individual, which seemed pretty much unique to each individual. The problem with the Bertillon system is that a criminal does not leave their Bertillon measurements at the scene of a crime. There's nothing at the scene of the crime which will tell you the criminal who was here had these Bertillon measurements. It is quite a good system for actually identifying an individual and allowing that individual to be re-identified. For example, if they're found at the scene of another crime, or if they've gone on to use a pseudonym or something like that. And it has no, in other words, it has no predictive value. But it is, if somebody commits a crime, has all their Bertillon measurements taken, then goes off, commits a crime somewhere else, and has their measurements taken, the two can be compared, and they can say, okay, the same guy committed the crime here, committed it over there. But the advantage of fingerprinting is that a fingerprint is unique. A fingerprint is an individual characteristic tied to one particular person. And people may, obviously they do not always do so, but they may leave fingerprints behind at a scene of a crime. And those fingerprints can be collected and they can be compared to standards so that an individual can in fact be identified. So these systems, as I told you, these have been used in many different guises but the very first case we know of where somebody suggested that the individuality of fingerprints, of a fingerprint, could be tied to a particular person was a case that was solved by this man Fold. And what had happened was there had been a robbery, I believe, at a hospital where he worked. There had been a robbery, and the thief had left fingerprints on a wall. And there were some suspects. They'd pulled people in as suspects. And Fold looked at the fingerprints on the wall, compared them to the fingerprints of the suspects. The first time anybody had ever done that. And he discovered that the fingerprints looked different. And he was able to exclude the suspects. That's a very important aspect of fingerprinting. It may point to an individual, but it may also exclude suspects and clear them. And that's what Fold did initially. Eventually, they did find a suspect whose fingerprints Fold believed matched those on the wall. And when confronted with that evidence, the thief confessed. So this was the very first case where that took place. And this was in 1880. And remember what else was happening in 1880? There was all the interest, the Sherlock Holmes kind of interest in policing was developing. And this sparked a tremendous amount of interest. In 1892, this scientist Francis Galton, who was, by the way, was related to Charles Darwin, Francis Galton published a textbook on fingerprints. And but it needs to be made clear. The book that he produced on fingerprints was a theoretical book, just about the structure of fingerprints and that sort of thing. Something about what he thought the evolutionary significance was and that kind of thing. It was not designed as a manual, for example, for forensic investigation of fingerprints. But other people read that book and began to realize the possible significance of using fingerprints. In particular, that Galton stated that the fingerprints were individual. They were unique to one particular person. They were unique, first of all, to each finger. You don't have duplicate fingerprints on your different fingers. Second of all, that every finger was unique in its fingerprint. He voiced that as opinion. That is not something that has ever been proved, except that it has never been disproved either. This person here, this is, I like this guy because this is somebody that not many people talk about. And his name was Vuketic. He was an Argentinian police investigator. And he actually took Galton's work on fingerprints and he developed a workable system for taking fingerprints and especially, most importantly of all, for classifying them. Because the problem is, look, we've got 4 billion people on the planet, right? And that's 4 billion times 10 different fingerprints that are possible. That's a huge number, an immense number of fingerprints. It's useless to have somebody's fingerprints if you can't have a system where you take those fingerprints and be able to compare them. Find the standard fingerprints and compare them to suspect. That is the most important step in fingerprinting. So you have to have some sort of system where all of these gazillion fingerprint records are organized into a system which is searchable. Nowadays, we use computer systems, as we'll hear. But for more than 100 years of fingerprinting, it depended actually on somebody being able to look at a suspect print, classify that print into a smaller group, go to a group of reference prints and sort through those reference prints one by one until they were able to find a match. A very lengthy, tedious, and highly skilled operation. But nonetheless, it absolutely depended on having a searchable database to compare suspect fingerprints to. So in the United States, actually, this was a worldwide famous case, but particularly famous in the United States. This is from the turn of the century, 1903, and I think I've told you this story before, but it bears repeating. These are two different men. One of them is called William West. The other one was called Will or Willie West. And the two of them, they look absolutely identical. At this time, the authorities were using Bertillon's system to identify people. And the Will West was a bad guy. He had been involved in several crimes and had been in prison before, and they had his Bertillon measurements on record. The other one, William West, was a good guy. And unfortunately, he had had this experience before of being mistaken for the other West. But he ended up being in prison for a really quite serious charge and swore his innocence. But his Bertillon measurements fit absolutely those of a known criminal. So he was in real trouble because he could not identify himself to the exclusion of the other one. But somebody looked at their fingerprints. The bad Will West was on file. And good Will West, they took his fingerprints and compared them. They were very similar, but they were very distinctly different. And based on that fact, he was freed from the charge, and they went out, searched, and found the other William West. It turns out that, in fact, it's not known how well they knew one another, but they were identical twins. And this points to something else that's important. Even identical twins do not have identical fingerprints for reasons I'll tell you in a minute. but even identical twins can be distinguished one from the other by their fingerprints, as they were in this case. The Bertillon system was not a popular system, but it was all that they had. It was a very tedious system. And this case and others led to the complete throwing out of the Bertillon system in favor of developing fingerprinting systems. The only thing which remains of the Bertillon system is what you see here, and that is that the Bertillon system was the first to use a mug shot, a profile, and a full face shot for identification purposes. Okay, so just take a minute and have a look at your own the fingertips at the ends of your fingers. And if you're in a good light, you should be able to see that there are distinct ridges which form a pattern on the surface of the fingers. Okay, you have similar patterns on the palms of your hands. You also do have them on your toes and on the soles of your feet, but not as distinctly as on the fingertips. And the reason that they're there is an evolutionary advance which improves our grip. And this, in human evolution, the development of this precise grip and the ability to use our fingers for very fine tasks has been an important driver in our evolution. And these ridges on the fingertips are friction ridges, and they improve our ability to grasp things and hold them. So that's what they're there for. And you'll see that they form a pattern. In this case, just have a look at the photograph. The finger, by the way, is, oh, sorry, it's that way, right? Pointing that way on its side. So first of all, have a look here. You can see in the middle here, there's a core there and there, which is in this case is in the form of a loop. It's a loop which is open there, and it's pointing this direction there. And that is called a loop. It's only one of the patterns that you see in fingerprints. So that loop is framed by other ridge lines. Here you can see around here, they're not participating in the loop. There are some over the top, and here are some over at the bottom here. And there is an important feature which we'll refer to several times, so I'll just point it out to you now. That is, if you have a look here, these lines here, they diverge here. These ones here, they run over the top. These ones here run underneath. But here lines actually move in, which actually diverge like that. And the point where they diverge, there's that sort of triangular area that is called the delta. And the structure of the delta can be very important in identification. So these are called the type lines above and below. And the type lines frame the actual pattern in most cases, except one which I'll show you later. So this is a loop system. But in actual fact, this loop, the presence or absence of something like the loop, is not the most important thing for fingerprint identification. Much more important in actual fingerprint identification are small features, and I'll point some out for you. Look at the delta here, and you see how that line diverges. It bifurcates, but it ends there. That's important. If we go hunting through, we'll see here, look, follow this line, this ridge here, and you see how it ends there. That's important. These little tiny characters in the fingerprint are called the minutiae. And they are, when a fingerprint expert is looking at a fingerprint, they are looking for those kinds of features, these small distinguishing features, because these features are developed in the uterus. They are developed by the fetus in the uterus, and they stay with you for the whole of your life. This gross overall pattern, the loop and the others that we'll see in a minute, these are useful for developing that classification system, for subdividing the fingerprint records into workable categories. But what actually distinguishes the individuality of the fingerprint are little tiny features such as this. We'll refer to them again, so don't worry about it for the moment. I just want to try and do something here. There we go. Okay, so here are the basic principles that underlie the use of fingerprints in criminal investigations. And that the overall arching one is that the fingerprint is an individual characteristic. Remember what we talked about before, individual and class characteristics. The fingerprint itself is an individual characteristic, and it ties to one person and one person only. It has never been, duplicate fingerprints have never been found. They are not even found in identical twins, as we have already seen. And the reason for that is that when the fingerprints are developing, as the fetus develops in the uterus, the distribution of the ridges and patterns is determined by very small things, like, for instance, whether the fetus presses its fingers up against the membranes that surround it, or if it's curled, it's got its hand curled. Things like this actually influence the early development of the pattern. So those are kind of random events that take place that determine the pattern. And once at a certain stage, the pattern becomes set. And once it is set, you keep it for the rest of your life. That is why even identical twins, right next to one another in the uterus, have different fingerprints, because they subject their developing fingers to different circumstances. One may have their hand pressed up against the side, the other has their hand curled, or the hands together, or whatever, to influence the characteristics of the ridges. So let's have a look and see how the fingerprint is actually built, and anatomically how it's built. And we're going to just have a look at these diagrams here. This is, I believe it's a diagram from your book. And I've included another diagram, which I've pulled in from somewhere else for a reason that I'll explain. First of all, if we cut through the skin anywhere on the body, this is what we find. We find there is a thin layer of living tissue on the surface here, which is covered actually by a layer usually of dead cells. This whole layer here is called the epidermis. There it is there. Below that, there is a very thin layer called the dermis. And the dermis actually has associated with it cells which divide to produce the epidermal cells. So it's a generative, there is a generative layer there. And when we look at how the skin is organized, we'll see, particularly on the fingertips, places like that, we see that it's organized into these islands like this. Can you see there and there and there? And each of those islands has a sweat gland which empties out through a pore. So these islands are arranged in lines or in ridges. And it actually is a reflection of the fact that the dermis underneath, which generates all the cells above, the dermis below is organized into these hillocks. And the hillocks produce these islands. The reason I included this diagram here is because this doesn't really show you the dermal papillae properly. These are called the dermal papillae there. It's not that clear in this. There's an association between these islands and the dermal papillae. So this is the dermis. This is the epidermis. Here are sweat glands penetrating all the way through. And the sweat glands penetrate. There are many, 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 many of them. And they continually produce a thin layer of sweat on the surface of the fingers. That is continually worn off, of course, as we're using our fingers, but it is replaced so that our fingertips, these ridges, are slightly damp. And that improves their gripping, the grip of the fingertips. In addition, the skin produces oils, and we continually pick up these oils and distribute them over the surface of the fingertips, so that when you press a fingertip to a surface, you leave behind a pattern. And the pattern is from the sweat and the oils, which are, when you touch the surface, you leave a line where the ridge is, and you leave a space where the valleys are. So the structure of the fingerprint is a very faithful replica of the structure of the pattern of ridges and valleys on the fingerprint itself. I don't need you to know all of the structure of the skin. What I want you to remember is the epidermis. Here in this diagram here, they've shown you the thick dead layer there, and it's not shown here. This is more like a fingertip here with just the epidermis. Underneath the epidermis, there is the dermis there, and the dermis is organized into these dermal papillae. And it's the structure and the organization of the dermal papillae that lead to the structure and organization of the ridges of the fingerprint. So here's the second principle about fingerprinting. The fingerprint remains unchanged during an individual's lifetime, excepting for one thing, and that is that the fingerprint may acquire scars if the fingertips are very frequently injured during our lifetime, and we do acquire scars nonetheless. There are many characteristics of the fingerprint which will persist through lifetime and enable that fingerprint, even if it is scarred, to continue to be identifiable. Some criminals, from time to time, have attempted to alter their fingerprints, often by using acid or by burning the fingers. It doesn't really work that well unless they burn extremely deep, which would be very, very painful and difficult to do, because in order to alter the fingerprint, you have to alter the structure of the dermis that is generating all of this tissue above. That's not an easy thing to do. In addition, even if the center of one part of the fingerprint is damaged, there are often enough characteristics on the remainder of the fingerprint to still identify it. So burning off fingerprints is not a successful endeavor. The patterns on the fingerprint can be classified. We can actually group people's fingerprints, and we can put them into a searchable database. Now, the issue of the uniqueness of fingerprints is one which people continually return to, because all that we can really say in a court of law is knowing the processes whereby fingerprints are produced and looking at all of the information about fingerprints which we have. No two fingerprints have ever been found which duplicated one another. Galton actually attempted to put a figure on this, but how accurate this is, nobody would know. But he suggested that there are 64 billion different fingerprints. And as I told you, our current population, I think, is 4.5 billion human beings. Probably about 5 billion human beings have ever lived, whatever. The chances that two fingerprints would repeat are extremely, extremely remote. And we assume that it simply can't happen that two people have the same fingerprint. So as I told you, once you touch something, even if you touch it lightly, the pattern left behind is extremely persistent. It is often almost invisible, but you leave behind a line initially of moisture, of sweat, but that sweat will evaporate and it will leave behind lines made of salts, which in fact actually often remain a bit moist because the salt itself attracts moisture, and of the oils that you have picked up on the skin. So, and that print left behind like that may last for for a very, very, very long time. It may last for months and still be usable. So most of those prints, as we'll hear, are practically invisible to the naked eye unless you look very carefully or unless you look under certain lighting conditions. And those we refer to as being latent prints. There are other prints which are obvious, which have different classifications, but most fingerprints are latent prints, and they have to be visualized. They have to be found, first of all. A skilled investigator will know likely surfaces and likely places to go and look for fingerprints. They then are visualized by one means or another. We'll see some of the ways in which that's done. And they then have to be recorded. And often we use a combination of actually photographing fingerprints in situ, in place, but then also collecting the fingerprints in a particular way so that they are preserved. Okay, so here are the basic fingerprint shapes. And these are, there are three that you do get a little bit subdivided, but there are three overall shapes. The first I've already showed you, and that is the loop. And here it is, here's the loop there. This we call the core there. It is framed by lines above and below. This is only part of the thing. And here you can see here's where the lines diverge there, and that is the delta there. This one is pointing this direction. A loop may point in either direction. It may come into the fingertip this way, or it might come in this way. And if we're looking at the hand, and this is pointing towards the thumb, that is an important characteristic. If it's pointing to the little finger on the other side, that is an important characteristic which would be recorded. So that's the loop. The next type is the whirl. There it is there. And that is a circular pattern there, as you can see. And this here is an arch. And the arch is like a very, very open-ended loop, if you like, forming this structure there. And both the loop and the whirl have a core. The arch has no core to it. When we look at the frequency of these in the population, the most common are the loops. 60 to 65% of the population have at least some fingers with loops on them. And you may have loops on one finger, whirls on another, etc. 30 to 35% of the population have at least one whirl on their fingerprints. And the arches are the least common. About 5% of people have arches like this. We'll see more structure to these in a minute. So here is a loop. Again, 60 to 65% of people have loops. It's important to classify these, as you will see in a minute, because we're going to use these, presence of loop, whirls, and arches. We're going to use it as a basic classification system for our registry, if you like. So if the loop points towards the little finger, like that, if the little finger was on this side, we would call that an ulnar loop. If it points the other way, and it points towards the thumb, that is called a radial loop. Here is the loop core there, as I've shown you. Around it are the type lines above and below. And where the type lines diverge like that at this point here, that is the delta. And the position of the delta and its structure, we're going to see in a while, may be a very important minutia, character of the minutiae. Okay, I think I've basically explained that already. All loops have at least one delta. So there it is there. That's the delta there. Here is the core. That is the actual structure, what gives the loop its structure. And the type lines frame around the core to define it as the loop. Okay, so here are whirls, and the whirls are actually quite complicated because there are different kinds. Here is a plain whirl. That's what we saw before. And all it is simply a set of circles, right? But all the whirls have type lines around them. There are the upper type lines. Here are the bottom type lines, and they have two deltas. There is one delta there, and here is the other delta there. And again, it's this, the delta is simply formed where the type lines diverge, one above and one below, to frame the whirl in the middle. So the whirls have two deltas there and there. The deltas sometimes in the whirls may be quite difficult to see because whirls can in fact become extremely complex. And for this reason, whirls are of particular interest in classifying the fingerprints. So this here is called a central pocket loop. It is actually a whirl. Although it looks something like a loop, if you look in the center here, it has a whirl there, not a loop like that, but a whirl. This is also classified as a whirl. It is a double loop. Here is a loop there, and here is a loop there. And it's easy to recognize. It's like an S shape on its side, like that, there. And again, the whirls all have two deltas, although the delta maybe, there's a delta, here's a clear delta there, and there's another delta there. The delta may be a little bit difficult to see in the whirl sometimes. Now, sometimes the whirls are very difficult to classify. It's just a swirl of lines, and it's difficult to actually state, and that is called an accidental. But they still have type lines above and below. They still have two deltas. There's one on that side, one on that side. But the actual structure in the center, it's very difficult to say what it looks like, almost like a very open double loop here. The whirl can have many different characteristics. And where we can't easily classify it, it's called an accidental. So these are the most rare of all of the forms, and these are the arches. And arches are characterized by the fact that they form, it's like a very open loop in a way, but opening symmetrically on either side, or more or less symmetrical, not completely symmetrical, but more or less symmetrical. So there are ridges on either side which rise and fall and exit on the opposite side. And this here is a plain arch here. It has no real core to it, and it does not have, these are not type lines, because the type lines frame a core. This has no, the arch has no core to it. And it does not have deltas either. Although you may see lines diverging, that is actually just referred to as a bifurcation. It is not a delta. So the arches do not have deltas, and they don't have type lines. All of the lines are participating in the shape, in the form of the pattern, in other words. These are the rarest. They sometimes, the arch can be very compressed and form almost like a spike here, and that is called a tented arch. This is an open or plain arch. This is a tented arch here. So, so those are just those shapes, loop, whirl, arch. Those are actually not individual characteristics. They allow us to put fingerprints in a class. Those are class characteristics. Everybody has loops, whirls, or arches on their fingerprints. That is just the presence of those is not an individual characteristic. It is a class characteristic, but it's a very useful one, because we're going to see that we can take those and we're going to put them into this kind of a formula to start classifying fingerprints so that we have a reference database which is easier to manage. We use the presence or absence of those structures in order to do so. And what is really important in the fingerprint identification are very small characteristics of the ridge lines. And their importance relies on the fact that once those ridge lines are formed in the uterus, they do not change for the whole of your life. So no matter how insignificant a characteristic looks, no matter how small it is in the fingerprint, it is a permanent characteristic. It will be there for the whole of that person's life. And so even the very smallest features become tremendously significant because nobody else will have them. They are individual characteristics. So have a look here, and we'll begin to see the kind of things which we're talking about. Here, for example, here is a loop structure, and we're going to follow some of the ridges and see what they do. First of all, have a look here and see how they terminate. See these ones here? That is a ridge ending, and its presence and its position is diagnostic for that fingerprint. Have a look at this ridge here and see how it divides into two. That is called a bifurcation. And again, its presence is diagnostic. It's where its presence and the place where it occurs, that is diagnostic. This here is called an island there. This here is called an enclosure there. So if we have a look at a real fingerprint, so here we have an example of a fingerprint. This is a suspect fingerprint here, taken from the scene of a crime probably. And this is our reference print. This is a print which was either on record already or which was taken from a suspect. So this is our ideal print, right? It's going to show us what we know. So first of all, this is not related to this, by the way. What is this? Yes, that is a whirl. And here, they're not showing the whole fingerprint. Here is the delta here, there. And the position of the delta is going to be important. Each of these markers here, all the way around, are pointing to things which this fingerprint expert has isolated as being important identifiers in this reference print. Here, for instance, is a bifurcation there. Here is the delta here, and the delta is structured so that it has this little short ridge inside here. There. But here's the delta. You can see it bifurcates, one arm going up here, the other arm coming down here. Here is a short ridge enclosed there. There's the ridge ending, and the other ridge ending is over there. It's a short ridge. Let's see if we can find, I just want to see if I can find an island. You have a look through here, you'll probably find, but what you're going to find, have a look at this here. This is the suspect print. And what the expert has done is they have isolated each matching minutia. So each matching minutia, each little tiny feature here in the reference is matched here in the suspect print. It is up to the expert to decide how many they are going to look at before they decide that this is a true match. Remembering that some fingerprints, for example, from an identical twin or from a sibling, might be similar. They may be similar, but they're not going to be identical. They're going to differ on all of these kind of little small things. And it's up to the expert to accumulate enough of these minutiae that they can state positively that in their opinion, in their expert opinion, this matches this. When this is presented in court, the defense may well challenge this and say, you know, how many did you choose, et cetera, et cetera, et cetera. And it is normal for a fingerprint expert to select far more than in their judgment justifies saying that these prints are identical. They overkill to cover the fact that this may in fact be challenged, can in fact be challenged in court. That is the defense's right. Okay, so I've given you this just as a little exercise. Here's a print, and this it's just a blown up print, and I want you to just go through here, and I want you to try and find these different features. Find 3 ridge endings, find 4 bifurcations, and see if you can find at least 2 little islands, ridges that are just sitting there all on their own. Remembering that this is the dark lines here indicate the ridges. Okay, this is a print which has been taken by rolling ink over the finger and then pressing it to a surface like paper. Now, there's 2 things. Unfortunately, if we were doing this in person, we would have a couple of little labs where we would do, and this is one of them. We would actually do this. You can do this for your own fingerprints. If you just take ink or acrylic paint or something like that and apply a thin layer to your fingers and then press it to paper and take your own print and see if you can do some of this analysis. And some of our succeeding analysis as well. Okay, so if an expert was to go through a single print, they would usually be able to find up to 150 different minutiae that could be used for identity. They don't usually do that many. About 30 or so is sufficient to identify a fingerprint as being the same between reference and the suspect print. But the expert must be prepared to go point by point through each of the ones that they've chosen and show why they believe that matches between sample and reference. And fingerprinting now is such a well accepted technique that it does not usually come under serious challenge. But in the early days of fingerprinting, it certainly did. But notice also that despite all of our modern technology, it still comes down to a human being physically examining a reference print and a suspect print in order to establish that. Computerized systems may well provide a range of reference prints to use. It gets through all that tedious having to sort through thousands and thousands and thousands of reference samples, but in a court of law, it must be an expert, a human expert, who comes and says, these 2 prints are identical. This print is from this person for the following reasons. So here's the way in which fingerprints are actually analyzed. The system use ACEV, and that stands for the analysis of the fingerprints, the comparison of the question print, and then the identification, and finally a final verification by an examiner to match the suspect print to a reference. So have a look here, and so the analysis part is actually to take that print, look at it and say, this is a print from such and such a finger, such and such, etc., and this is how we proceed to examine it. The comparison is done at 3 different levels, which I'll show you now. Those 3 levels allow the expert, hopefully, to be able to identify a particular individual, and that has to be carefully verified. And it is this verification which will be presented in court. Okay, so here are I said there were 3 levels of identification. The first level is looking at that overall pattern, the overall patterns, and that is whether it's loops, whorls, arches, etc. This is for the reason that we're going to use these as class characters to put our fingerprints into smaller groupings to make it easier to actually trace, actually find reference prints to compare them to. Level 2 is where the expert looks and identifies the ridge characteristics, all of those minutiae. They actually label and identify between reference and suspect and compare the minutiae. And then level 3 looks at things which may have been accumulated on the fingerprint, which do not really relate to the origins of the ridges. In other words, things like scarring on the fingertips, wear, calluses, which may develop on fingertips with particular occupations and usage. All of those sorts of things are added to the identification. Okay, so this is how it's done. It'll sound a bit strange when I just describe it to you, but I've got an exercise for you to perform. And so we use the overall patterns, loops, whorls, arches, etc., to classify the set of prints into particular categories. So, and this is the way it's done. Fingers are paired up. And all of these, the figures that we're going to end up with here are a numerator. And then below is a denominator. So the easiest way for me to get you to do this yourselves and have a look at your own fingers. Get into a good light. If you have a magnifying glass, it will help you enormously. If you want to do so and you are able to do so, then you can ink your fingers and take prints and then examine those. And that's what we would do if we were in a lab. Okay, so the first that you do is you look at your right index finger and your right thumb. So index finger and thumb. All that you're looking for are whorls. That's all. Ignore loops and ignore arches. Okay. So this works only by using the presence or absence of whorls. So right index finger, right thumb. If you have a whorl pattern on your index finger, you score 16. If you have a whorl pattern on your thumb, you score 16. Index finger is numerator. Thumb is denominator. Have a look here. Sorry. Right index, right thumb. 60. There's a whorl, 16. If there was a whorl here, 16. There's a whorl here, 16. If there's no whorl here, 0. Okay, we 16 over 0. If the thumb had no whorl, you get the picture. So that's 16. Now we move on. to the right ring finger. So is your right ring finger there, and your right middle finger there. Numerator, denominator. Okay, and if you have a whirl on either of those, it's 8. So 8 for with it. Next one, your middle finger. Your left middle finger and your left ring finger. Left ring finger and left middle finger. And if you have a whirl on either of those, it scores 2. Then your left little finger and your left ring finger again. Left little finger, left ring finger. And if you have a whirl pattern, it scores 1. And that now you will have gone through all of them. And for each of these, you would have a particular number in. Add all of those up for the numerator, add all of them up for the denominator, and add 1 to each. 1 there and 1 there. And that gives you, that fraction gives you your primary classification. And if you were a fingerprinter, a fingerprint expert, you would work all of that out really quickly, and it would tell you immediately, go to this particular collection. Go to this collection of fingerprints, because those fingerprints are going to be, if there's a match, it'll be somewhere in there. It's just, all it is a way of providing a sorting system, so that going through and doing all of these comparisons is a little less tedious. Otherwise, you'd have to go through everything, all of the fingerprints that you have. When you do all of this, you work out this fraction. You realize that, in fact, remembering that loops were the commonest, right? In actual fact, 25% of the population, when you do all of this, all of these are 0, because they only have loops, or they loops, or very rarely arches, right? The loops are excluded because they're so common. Arches are excluded because they're so rare in this classification system. Only whirls are counted. And for 25% of the population, the fraction that they end up with is 1/1. You'll remember you added 1 to the numerator, 1 to the denominator. So in other words, everything else was 0 for them. It's just a sorting mechanism. But work it out for yourself, and you'll see how it works. So that is a class designation. Those are class characteristics. But the minutiae, comparing minutiae, are in fact individual characteristics, and very, very powerful individual characteristics. You do not, in fact, have to count that many matching minutiae to be able to say that this print matches to a reference print. But usually, as I say, 20 to 30 characteristics at least are accumulated in order to really prove the point. All right, so we'll stop there, and we'll talk next time about how latent prints are recognized at the scene of a crime, and then how they are treated subsequent to that. I'll see you then on Friday.